Okay, guys. So we're going to be moving through the next part of LT5. Okay, so this is going to be done predominantly on your graphing calculator, which you guys have access to on your Chromebook. So this is the problem that was in our notes packet, if you would have gotten a notes packet. And you do have this linked in the agenda as well. So what we're going to be doing is identifying some of the key features of these different equations based on what's being asked here, but then also on different forms of the equation. Okay, so this one is what we call vertex form. This is what we talked about during transformations, and it just means that you can easily identify the vertex from this format. So our vertex would be 3, because remember it's the opposite of what you think, 3, -2. Okay, so just for reference, that's what your vertex would be. Okay, 3, -2. Let me get here. Right, and that again is based just on this number and this number. Okay, so 3, -2 for our vertex. Now for our x-intercepts and our y-intercept, this is where we're going to go to our calculator. And we're going to type it all in our calculator. So we have 2 parentheses x minus 3 squared minus 2. And then we're going to hit graph. Okay, and there's our parabola. Now, you can also identify the vertex from here, okay, on your graph. It is right down here. And we can also look at it a couple different ways. So the other option we have with our, let's look at the graph first. So for our x-intercepts, remember that's where your graph is crossing the x-axis. So you're looking at this point right here and this point right here, okay, where your graph is crossing your x-axis. And then your y-intercept is where your graph crosses your y-axis, which in this case is way up here and we can't see it. Okay, but we do have a way to see those values without having to guess them. Okay, and we're going to use our table for that. So if you hit second graph, you will see your table. Okay, now the way that you need to interpret these graphs for the table is understanding that your x-intercepts, okay, mean that your y is equal to 0. Okay, so if I look at my graph again, here's my x-intercepts. This point we think is positive 2, 0. This one looks like it's probably at 4, 0. Okay, but if I look at my table, I can test that to see when I go down here, notice that my point is at 2, 0. And if I keep going down a couple, I see that I have one that's at 4, 0 also. So just by looking for your zeros on here, you can look for, that'll tell you where your x-intercepts are. So 2, 0 and 4, 0. Okay, so we'll put that in our notes here. Okay, and then our y-intercept. Now our y-intercept was kind of hard to find on our graph because we couldn't see it, but we know that our y-intercept would be where x equals 0, okay, somewhere up here, but we know that x has to equal 0 because it's on this axis. So what I can do is look through my table to where y equals 0. I'm sorry, where x equals 0. Sorry. And if I look on the left side, those are my x values. I see that it is at 0, 16, which is why we can't see it. It's too high up. Okay, so 0, 16. And that gives us our x-intercept, our y-intercept, and our vertex. Okay, so now we're going to try the same thing, but when the equation's in a different format. Now, when we do this in person, we actually do these by hand. So you guys are actually getting kind of lucky this way because this is going to be a lot easier. We're only doing it on the graph. All right, so we're going to clear what we have before, because if you don't clear it, it's going to show both graphs. So we're going to type in x plus 6 times x minus 2. Okay, and then we're going to hit graph. Now this one is also looks like it's very hard to see. Okay, we can see where our x-intercepts are. It looks like it's at 2, 0, and then maybe 1, 2, 3, 4, 5, maybe -6, 0 is our other one. But we can't really see our y-intercept, and we can't see our vertex. But because we have that table, we don't really need to be able to see them. And then we can also verify what our x-intercepts are also. So we're going to go to our table. And let's look for our x-intercepts first. Remember we said that our x-intercepts are where our y values are 0. So I'm going to look down this side. Oh, and there's 1. Okay, so I get 2, 0, which is one that we thought it might be. I thought our other one was at -6. Let's try going the other way. And there we go, -6, 0. So we were correct in assuming that those were our x-intercepts. All right, now for our y-intercept. Okay, in the previous problem, I told you guys that your y-intercept means that x is 0. So we're going to scroll down here to where x is 0, and we get 0, -12. Okay, which again would make sense because it was further down our graph. Okay, we couldn't see it. Now for our vertex. Okay, your vertex is a little bit trickier to find on here. That's not as obvious as the zeros. But one way that you can determine your vertex is by looking to see where your points change direction. Okay, keep in mind that your parabola comes down like a U like this. So your values are going to be decreasing, and as you get to here, it's going to stop at a point and then it's going to start going up. Okay, so we're going to look at our x values to where we think the lowest point might be. It looks like it might be here. Okay, so again, I'm looking at my lowest y value. And if you can see, it goes from 0 down to -7 to -12 to -15 to -16. As soon as I hit -16, it starts going back up. -15, -12, -7. So you can see that's where your graph kind of turns direction. And it looks like our vertex is at -2, -16. Now we do have a way to check that. Okay, and this is just going to be some extra calculator practice here. So if I look at my graph, okay, here's my graph. I have a couple different ways. I can look at my window and I can change how low my graph goes. It looks like this is at -16. So if I change the y, the minimum, okay, so the lowest y value that my calculator is showing right now is -10. If I change that to -20 and then I graph, now I can see the whole thing. And this gives me a couple different options. I have this trace key. Okay, with trace, I can enter in any x value. I can type it in and it will tell me what the y value is. And this one happened to put it right on the y-intercept. So that gives us another way of verifying this. The other thing I can do is I can use this calculator function. Now, this graph has a minimum because it has a lowest point. So I'm going to go to my calc functions and I'm going to look at the one that says minimum. Okay, now all we're going to do here is choose any point on the left side of my graph and hit enter. And then I'm going to choose any point on the right side of my graph and hit enter. And then I enter again and it gives me 2, -16. Oh, sorry, this should, -2? Yeah, sorry, -2, -16. And you can see that that matches up. So you have a couple different ways of checking these different values. Okay. All right, our last thing that we're going to go over for this one is rewriting in vertex form. Okay, so we're going to take this equation and we're going to graph it, and then we're going to identify the vertex, and then we're going to write it in vertex form. Okay, this is normally, again, a lot longer process that we would go through to do it by hand, but you guys don't have to this year. So I'm going to type in x squared plus 6x plus 14, and I'm going to graph. Okay, so in this case, if you ever want to move your window back to the normal, you hit zoom 6, okay, the standard one. Now, I'm going to look at my table and I'm going to check the minimum just so we can kind of see. So I'm looking for the lowest y value, which looks like it might be at 5. Okay, so notice here, I go from 14 down to 9, down to 6, down to 5, and then it changes direction and starts going back up the same way on the other side. So it looks like it's probably at -3.5. But let's go ahead and check it again. So we're going to do minimum, and I'm going to pick a point anywhere. See on the bottom here how it says left bound? I just have to pick anything on the left side of my vertex, and then anything on the right side of my vertex, and hit enter. And sure enough, it does give me -3.5. Okay, so now that I found my vertex, now I'm actually going to write that in vertex form. So if you remember, that's y equals, we have no indication that it's any other y value or any other a value, okay? And then it's going to be x. Normally it would be minus a negative 3. So that's going to become plus 3 squared and then plus 5. And there's your vertex form. We've got one more type of problem that we're going to go over in the next video.